Now we will be going through the preparation checklist located in Book 1, Chapter 4, Page 2. It's often helpful to photocopy this page and cut it out and paste it to your instrument, and that is a good reminder of the checks you should do every day when you use the instrument. To begin, we will go into New Measurements. Press F4. The preparation checklist is broken up into 3 sections. The first section is a list of items that you should do while the instrument is warming up. Box B is a list of things you can do after the instrument is warmed up. And Box C is items that you should do when you're clamped on to your first leaf. We will start with the items during the warm-up section. The first item is to insert a CO2 cylinder and put it on your instrument, and we have already done that. The second item is to check your temperatures and to make sure that they are all reasonable and that they are responsive. So go ahead and put line H up on the display. And here you can see T-block, T-air, and T-leaf. T-block is a sensor that's embedded in the block of the 6400 sensor head. T-air is a sensor that's located directly under the leaf mixing fan inside the sample infrared gas analyzer. And T-leaf is your leaf temperature thermocouple, and that is up in the chamber where your leaf is. Just look at them and make sure that they are reasonable for your current location. Point number 3 is to make sure that your light source and your sensors are responding and that the values seem reasonable. Your light values are located on line G, so if you put line G up on the display, you can take a look at your light sensors. Now we are inside a laboratory, so the external quantum sensor is reading quite low. If you were to take your instrument outside and you had a full sunlit day, you might expect a light intensity of 1800 to 2000 micromoles. So you can see inside a typical room, the light intensity is actually quite low. Go ahead and turn your lamps on, and you do that by going to menu level 2, which you can navigate to either by pressing the labels button or by pressing the number 2 on your keypad. F5 is your lamp control key. Go ahead and select that and arrow down to quantum flux. Go ahead and enter a relatively low value, and the idea is we just want to make sure that we can visually see our light source turn on, and we want to check our par-in signal and make sure that it corresponds to what we're asking for. When it's on target, you'll notice the asterisk next to the par setting will go away, indicating that we are on target. And you can see on line G, I am reading within about 1 micromole of what I've set the intensity to. Go ahead and turn your light source back off. Next, we're ready to check our pressure sensor. Pressure is located also on line G, and again, you just want to notice if it's a reasonable value, and you'll have an idea for your current location and what you would expect pressure to be. Here at our location, we would expect anywhere from 96 to 97.8 or so. So we're clearly within the range of expected atmospheric pressures. The next item we're going to check is our leaf fan, and your leaf fan control for the LA6400 XT is located on menu level 2, F1. And the idea is to open up your chamber so that you can hear your fan running, and then we will go and we will change our fan setting. You'll notice that there are controls in here that you can dial in either a number for the voltage that you want the fan speed to use, or you can hit S for slow or F for fast. And go ahead and just turn it down to off. So if you press O, you'll turn the fan off. And I want you to make sure that you can hear a change in noise when you do that. Okay, go ahead and turn your fan back to fast. And again, you can either press 5 or the letter F. And you should hear the noise come back to the way it was originally. Next, we want to check our flow control. So we will go and ask for a maximum flow of 1,000 micromoles. And if you press the home key, it will reset your display to A, B, and C, and you will notice that flow is being displayed on line B. Now, we want to verify that your maximum flow is above around 600 micromoles. If it's above that, then that means you have a good flow. Now what we want to do is check our chemical tube restrictions. Go ahead and put both of your chemical tubes on full bypass. Now that both chemical tubes are on full bypass, go ahead and start with one of the chemical tubes, and it could either be the desiccant tube or the soda lime tube, and move it from the full bypass to the full scrub position. When the flow stabilizes, check your flow rate that's indicated on line B. You should have seen a reduction in flow when you move from the full bypass to the full scrub position. And you can see on my instrument, my flow dropped about 4 micromoles. Normally you would see a drop anywhere from 0 to about 10 micromoles of flow. If you see much more than 10 micromoles of flow drop when you go from the full bypass to the full scrub position, you could assume that there must be a flow restriction in your chemical tube. Flow restrictions can show up in a number of places in the tube, and all of those are covered in great detail in Book 3 of the LA 6400 manual. Now that you've finished the first chemical tube, go ahead and choose the next chemical tube and move its scrub knob from the full bypass position to the full scrub position, and check to make sure that it doesn't drop by more than another 10 micromoles of flow. With my next chemical tube, you can see that my flow dropped by another 2 micromoles per second of flow. So both of my chemical tubes are just fine. Now we are ready for Box B, the after warm-up section. The first point in Box B is to check our flow 0. In order to do that, we need to turn our pump off, and that's what says currently flow at 1,000 micromoles per second. Go into F2 and arrow up to pump off. You could also press the letter N. After you turn your pump off, you should notice an error message that comes up alerting you to the fact that your pump is off. Now, if you are trying to see something that's behind an error message and you would like that error message to go away, you can hold your control key down and the letter Z or Z, and you will see that error message go away. And now we can easily view what our flow rate is. And you can see that mine is slightly negative. You typically want a flow 0 of around 1 micromole or less. And you can see that I am within that range. One other point I should make here is that because our leaf fan is turned on, we could actually be getting some flow coming from that leaf fan and returning through our tubing back to the console and through the flow meter. So you might see a negative offset simply because your leaf fan is turned on. So to truly look at your 0, go ahead and turn your leaf fan to off. And now check your flow 0. and I am well within the range that I want to be. Before we leave and go to the next point, go ahead and turn your leaf fan back to fast and turn your pump back on and ask for a flow rate of 200 micromoles. Now we can adjust and latch our chamber. In order to properly latch your chamber, it's a good idea to turn the tension adjust knob in a counterclockwise direction and then clamp your handle and look at the space between the two gaskets. Then move the tension adjust knob in a clockwise direction just until the gaskets meet. Then you can open up your chamber and give that tension adjust knob one more complete rotation. And that should be tight enough. Then you can go ahead and engage your handle. So go ahead and do that, and we will begin with the next point. Now that your chamber is closed and latched, we can check our CO2 zero and our water zero. Both of our chemical tubes need to be in the full scrub position. As you can see, my CO2 reference and sample are dropping down and they're both approaching zero. What we want to see is that the CO2 reference and sample should be within about 5 micromoles of zero. And you can see the reference analyzer is currently there. The sample analyzer is dropping much slower. And the reason for that is you have a much bigger volume in the infrared gas analyzer of the sample chamber, and you also have a bigger volume where your leaf is in the chamber itself. And so it does take a little bit longer time to flush out the sample analyzer. And you can see it is slowly approaching the target that we're interested in. Next, we can check our water IRGAs. And for the water IRGAs, we want to make sure that our analyzers are within about 0.3 of a ppm of zero. And you can see that these are both a little bit high. So I'm going to check my desiccant and make sure that it is of good efficacy. Now that my water IRGAs are on target, I can go to the next point, and that is to check our leaf temperature zero. Go ahead and put line H up on the display. And what we want to do is disconnect the purple connector of your leaf temperature thermocouple, and you'll see that running right underneath your bottom chamber. And go ahead and pull straight out on that connector to disconnect it. With the purple connector unplugged, you should compare leaf temperature to block temperature. Block temperature is the reference junction for the leaf temperature thermocouple. So, when the leaf temperature thermocouple is unplugged, the reading on the new measurements display for leaf temperature should be within about 1/10 of a degree of what the block temperature is reading. And you can see that on this instrument we are in agreement. If yours needs to be adjusted, there are instructions in Book 3 of the manual on how to do that. Once you have verified that your leaf temperature thermocouple is zeroed, go ahead and plug your purple connector back in. We are now ready to set our reference CO2 concentration. To do that, we go to Menu Level 2, F3, where it says Mixer Off. We want to go down and select a reference CO2 concentration, and we are going to choose 400 as our target. So we don't need to dial in the concentration because it's already set for 400. If you press the Home key, it will reset your display lines to A, B, and C, and we can monitor how our CO2 concentration is climbing up and approaching our target. The first time you use your CO2 mixer, it takes several minutes to reach your desired set point. And the reason is there's a pressurization that needs to happen in order to reach your CO2 target. When you go from a lower concentration to a higher concentration, it will take slightly longer than it does if you reverse the situation and go from a higher concentration to a lower concentration. If you feel that it's taking longer than it should to reach your set point, there's a CO2 mixer calibration routine located in the calibration menu, and you can run this when you feel that it's taking longer than it should to reach your first set point. And what this will do is it will generate another calibration curve for your instrument. This is something I don't recommend doing on a daily basis, but it might be helpful to do it on a weekly or monthly basis. And as you get oil that builds up in your cigarette filter and in the tubing of that CO2 source assembly, or even the oil can move past the cigarette filter, past the little copper tubing, and could actually plug a centered flow restrictor that's located on the source assembly. If that happens, there are spares in your spare parts kit, and there are instructions and pictures on how to do maintenance on this portion of the instrument, and those are also located in Book 3 of the LA 6400 manual. Now that our CO2 concentration is close to being on target, we want to move our desiccant so it's midway and we allow some of our ambient humidity to go into the chamber. Ideally, we want to start with about 50% humidity in our chamber. So go ahead and move your desiccant in the middle and see how much humidity you can get in your chamber. Now that the reference and sample concentrations are stable, we need to check for leaks in our system. We want to go ahead and breathe around our chamber, kind of like you are blowing out a birthday candle. And we want to look at line A at CO2 sample and water sample and make sure that we don't see any jump in concentration after we breathe around the chamber. And that will indicate that we are fairly leak-free, at least in terms of the bulk air leaks. So go ahead and do that and make sure that you don't see a rise of more than about a ppm CO2 around your sample chamber. If you're okay and all of your concentrations are still stable, then let's go ahead and match our IRGAs. And we do that on menu level 1 and go to F5 match. When you're entering match mode, you'll notice that there is a time delay to allow flushing of the reference IRGA. Once the reference IRGA has been flushed, you'll be in the match mode screen. And you will notice normally what appears is your CO2 concentrations for both your reference and the sample, and your water concentrations for the reference and sample. But you can change the display line to really any display line that you would like to see. So right now what we are doing is we are taking the air that's in our sample chamber and we are flowing it through our reference chamber. And at this time, because both chambers, both analyzers, are seeing the same air, they should be reading the same concentrations. If they are not, you are allowed to match your IRGAs, and that's what we're going to do now.